Topic is novel meta-heuristic approaches to nurse roasting problem in Belgian hospital, and this is present by Laxmi, Chidri and Sonam, Nahar, and we'll be seeing about the introduction, problem description, solution framework, meta-heuristics and hybrids, a multi-criteria approach, and the conclusion. First, let's see the introduction. As there was increased pressure in the work in a hospital, and there was no rostering system deployed for among the hospital. So this made one of the employee resources more efficiently, and the resource efficiency is increased, and the station satisfaction level of patients also increased. While doing this, there are several factors to be considered, like assigning the nurse roster to the personal members, and they generated a model called advanced nurse rostering model. And there were some approaches which were concentrated on the short term problems, there should be a number of personals in the ward, the required qualification of the nurse, and the a definition of a shift type. So we'll see in detail in the upcoming slides. Apart from those factors, they have some problems like which are not considered but they were affecting the solution strategies, like a shift time divided over the several nurses assigned to different wards temporarily during emergencies, certain preferences by personal members. So all these problems were addressed by many of the scientists and the personal managers over many years. After that, there was a larger emergency and there were more problems, which were presented a real problem for our researchers. So for this, and there was a flexible planning system should incorporate as much as knowledge is possible to provide the personal manager or head nurse satisfying all the objects of that personal. So this was the brief introduction. So now let's discuss about what was the problem. So the problem was that the hospital was organized in a ward with fixed activities, and each ward has its own team of nurses, and the personal members in the ward should belong to some skill categories, and that should be divided in based upon like their qualification level or the responsibility, or depending upon the job description, or depending upon the person experience. So if there is a person with more experience and they have written more exams or something like that, then they should be in the higher skill categories. And there should be some work regulations for the hospital personals, and the description should be like it's a part-time work or a night nurse contract, or they are working for weekends, like that. And a shift type is a predefined period with fixed start and end date in which personal members can be on or off duty. And the cyclic rosters are not common in the Belgian hospital. That is nothing but the different schedules were there for each planning period. These are and and planning periods can be a couple days before the few months. There should be a fixed planning period for the hospital, and they created a trade-off method that is nothing but nurses should know their schedule far in advance, but not too long in terms. It will be difficulty because staff needings fluctuating constantly and are accepting predictable long terms. So here is a shift type method. It is nothing but the morning shift is from 6:45 to 2:45, and the late shift is like 2:30 to 11 10, sorry, and the night shift is like 10 to 7 morning. So here is a basic simple table roster example for 5 people who are working for a week, and their shift for Mondays, Tuesdays, and like that. Daily their shift is changing, and there is a schedule in which shift assignments are stored, and assignment assigned to units should be a minimum allocation in every schedule, and the mainly expressed like two terms. One is hard constant and soft constant, so we'll discuss in later. So each shift type correspond to an assignment unit in the practice. So what are hard and soft constraints? Hard constraints are nothing but which should be satisfied for all the costs. For example, take an shift assignment which is gave to a personal member, then that person cannot be assigned twice same shift for a same day. And the one more condition is like a worker must be able for that a particular category or skill to perform that shift, and these all things makes a feasible schedule to meet all these hard constraints. And whereas soft constraints, uh, those which can be violated, that means there is no such restrictions like that. So that means they are customizable, and they are divided into three categories. The first one is the certain constraints hold for the entire hospital. For example, there should be a minimum time between the two assignments, or allow alternative skill categories in certain situations. And the second one method is like, if there is a set of soft constraints and the same people with same contract, then there should be a values for those users, like maximum number of assignment in the planning period, minimum or maximum number of consecutive days. So these are basic example for the soft constraint. And when individual personal members have agreement with a personal manager or a head nurse, then the certain constraints are implemented, like they should be worked on day off, or they should have some shift to work there, and they have been given a requested assignments to do that. And the solution framework. So, to overcome all these, they found a solution called an aroma model, and that they have driven evaluation function that estimates the quality of schedule. So, as I told, that hard constraint have to be satisfied for the cost reason, and only soft content violation contribute to that quality. A solution that does not meet hard constraints does not qualify the feasible solution. So if you want to make us algorithm more simplifiable, then we require a very little memory and computation time. So this have useful for evaluating intermediate solution when we are exposing a large space. So let's briefly discuss about the anoroma overview. So here there's nothing but we have to decide a base schedule to start the date. When we are done, then we have to do the soft constraints and the coverage requirements. So after doing that, if there is a minor changes in the schedule, we have to do that. After doing the minor changes, then we have to create a new schedule. After creating that, we need to create a better iteration for that schedule in the base schedule. So stop by so various meta heuristics are used to perform and the hospital can choose which one has to be better and which not to be used. Planning procedure. So in this, the algorithm is splitted into many modules, and each hospital have to modify the result for that procedures in order to control over the results. So let's discuss each modules one by one. So the first one is the consistency check. So here, if the hard constraints are checked first, and if there is no feasible schedule is possible for those hard constraints, and after that we'll go for the soft constraints. So in that cause of constraints we have two options. One is accept and another one is repair. So in accepts, the user only allows for the less persons in the certain awards or workers to perform their skill categories, like, but in the repair there is a extent for the constraints to find an feasible schedule. And the next one is the freezing. So in this method the roster algorithms have various methods. To prevent the algorithm from freezing, we have to modify from some of the schedules, like some hospitals prefers interaction and the timetables of certain nurses manually, and the personal preference of the hospital staffs. And no matter what the schedule or frozen, there should be an emergency staff for the reassignment. And the initialization has also one of the part of the schedule, part of this planning procedure. And here we have to construct this, we have two feasible solution. And the first phase is that we need to input the load, and we can plan that for the initial schedule. After that it can be copied from the previous schedule or the current planning period. If it is exists, then we can take that plan. And the second phase is that, um, make a feasible schedule by choosing or removing assignments until that we satisfy the some of the hard constraints. And the order of skill categories. So in this it can be done by the if the person is belonging to some a skill category, and we can take a small part entire staff, and we can assign as much as can we can lower that. And the other one is, one skill category has to be stopped, then the algorithm moves on to the next skill category and temporarily freezes the already assigned shift. And the planning procedure time interval is nothing but whatever the time required to provide an alternative way for expressing the coverage needs. And here, if a hospital has defined a large number of shift types, then it can have many kinds of part-time works. With all these options, we can concentrate on the advanced formulation of requirements to find the best personal coverage. And the last one is the coverage procedures. Here so many options are available, like minimum, preferred and post plan. So in that minimum we are setting some of the coverage as an hard constraints. After that, in that, staffing is not allowed to be lower than this number. And the algorithm should attempt to reach the preferred staffing level, but it not to be planned or required. And in the post plan, after running the meta heuristic, so we'll be seeing in detail about the meta heuristic. And if the staffing levels are not met, then the hours may not be added to those with at least amount of hours.
Hi, I'm going to explain you about meta-heuristic and hybrids, and after that, the rest of the part. Meta-heuristic is nothing but a method which is applied to a problem characteristic to dynamically modify the environments of the search heuristic. The search space can be improved by combining short-signed search with a greedy search in the border environment. So this method is developed just to solve the nurse roster problem, which is related to neighborhood. If there is a better solution can be found after a number of iteration. For new and updated environments to be considered as a solution, it should satisfy hard constraint. The meta heuristic that we developed to solve nurse rostering problems change neighborhoods when they cannot find a solution during the number of iteration. All the solution in the environment must satisfy the hard constraints. Although the cost function is driving force for the heuristic, it may remain blind for the improvements if cannot interpret a certain problem's characteristic. A few environments were designed only for the purpose of finding such improvements. Uh, the example includes single day shift neighborhood, a soft constraint relation neighborhood, swiping large section of personal schedules. So what is a single shift day neighborhood? So this is the simplest environment which contains all the solutions that differ from the current solution by moving one assignment to another person's schedule. So this figure illustrates the neighborhood for an example with four nurses and four different shifts. Nurse A can replace the head nurse and other two regular nurses cannot. The arrow in the figure shows that only possible move that do not violate the hard constraint. Moving the head nurse day shift to nurse B's does not result in a feasible solution. Neither does moving nurse A's E shift to the schedule of the head nurse. Soft constraint related neighborhoods. The planners with the practical experience were more often concerned about violation of certain soft constraint than about the overall solution quality. This resulted in a particular set of environments that is considered the search space in completely different way. They are blind for the global effect of the move, but attempt to violate the quality of roster by only considering the soft constraints that are being addressed. Of course, this approach is completely opposed to the idea of general evaluation of of the function from the individual constraint. Therefore, entire search procedure should not end immediately after exploring the neighborhoods. For example, of such environments looks at the weekend constraint, over time, alternate qualifications, personal preference, etc. A special neighborhood only look at the most violated constraint, no matter which constraint it is. Now moving on to the swiping large section of personal schedules. Unlike the previous two, in which neighboring solution only differs in the position of one single shift type, this set this set of neighborhoods look at the schedules that differently from the current solution. The shuffle environment consider switches from a part of the worst personal schedule in terms of this evaluation function with other than schedule. Instead of moving single day shift, all the assignments in longer period that can be one day or the number of day that equals to half the planning period that are switched. A similar environment is called as greedy shuffle. It consists of all the possible shuffles between any two people, relocating the larger group of the shift that once is often less harmful for the quality of the solution than moving the shifts around. The drawback applying this category of neighborhoods is that the number of neighboring solutions is very large and iteration thus requires large amount of computational time. Hybrid taboo search. It is an algorithm which is integrated in the software package that is based on NROM. One of the major benefit of the search taboo search is the ability to escape from local optima by preventing the search from going through the same areas again and again. As long as there is an improvement, taboo search behaves like a steepest descent algorithm for finding a solution. There are aspiration criteria to prevent solution in the taboo part of the search space being ignored. The efficiency of the search can be increased by applying diversification. The basic the basic algorithm is a combination of taboo search with a single day shift neighborhood that I explained to you in the earlier slides. The certain characteristics of an encountered solution are put together into a taboo list in order not to circle around again and again. Instead of carrying a random diversification, when a basic algorithm cannot generate a better solution during a number of iterations, author opted for implementing more problem specific steps. For different neighborhoods that we introduced here are useful in this respect. They are particularly useful when considering the following, like the soft constraint on full weekends, improving the worst personal roster, and the third is all large improvements between two personal rosters. So the output and the result is taken into the two parts, that is TS1 and TS2. So TS1 is nothing but the fast planning. When the taboo search does not find the improvements, the diversification consists of searching in the weekend environment, and after that there is a shuffle in the environment. This process is iteratively repeated until the global stop is reached, and the TS2 is the throughout planning. So it is a combination of TS1 and greedy shuffle. This combination requires more time, but the results are of consistently high quality, especially since the greedy step is carried out at the end of the calculation. The computation time is kept under control. The confidence of the users is high because all the manual modification make the obtained solution worse. Mimetic algorithms. The population based techniques can overcome the problems that occur when single solution involves. We briefly introduced a set of mimetic algorithms for personal rostering that make use of crossover. The crossover is nothing but the copy of good characteristics of previous generation and the mutation for the random diversity. The mimetic algorithms apply local search on every individual for a of a population. The combination of the computational time is large, but the result demonstrate that mimetic algorithms offer more to rostering than the sum of the component algorithms. The simplest mimetic algorithm, it it applies the steepest and descent neighborhood from each newly created individual. The planning order of qualification remains unchanged. A simple tournament selects the best parent. The first child is obtained by copying the best personal schedule from the first parent together with the best one from the another parent. A personal schedule is simply to work schedule for one particular person. All the, all the other personal schedules are copied randomly from both the parents. For second child, we start from the best solution of the other parent, and then both the new individuals are normally infeasible, but they are repaired by randomly adding or moving assignments until the coverage constraints are met. Below are the mimetic algorithm variants. The first one is simple mimetic algorithm. It applies steepest and decent solution on each newly created individual. The planning order qualification remain unchanged. A simple tournament selects the best parents. The first child is obtained by copying the best personal schedule from the first parent together with the best one from the other parent. A personal schedule is simply the work schedule for one particular person. All the other personal schedules are copied randomly from both the parents. For second child, we start from the best solution of the other parent. Both individuals are normally infeasible, but they are repaired by randomly adding or removing the assignments until the coverage constraints are met. The second one is diverse mimetic algorithm. This algorithm is based on the simple mimetic algorithm, but planning order of skill categories is randomly chosen in the local search step. Third one is diverse mimetic algorithm with random selection. It applies the general feature of the diverse mimetic algorithm, but all the personal schedules are randomly selected from the both parents. The next one is mimetic algorithm with crossover. A random assignment until unit is generated for each person in the schedule, and at that point personal schedule from two parents are combined. Again, the schedules are made feasible and the steepest descent algorithm is carried out on each individual. And the last one is mimetic algorithm that copies the best X assignments. For every personal schedule, the algorithm selects the assignments that include highest increase in violation when removed. In case when the best assignment are the same in both parents, only X are copied to the next generation. The diversity is obtained by randomly making these schedules feasible. Afterwards, the local search algorithm improves the individuals. As we have discussed and explored the various algorithm variants of combining TS and evolutionary methods, we have to consider the following approaches like multi-starts TS with random planning order, which enables a direct comparison between TS and mimetic algorithm and hybrids. Finally, the best solution is improved with the greedy shuffle. The second one is mimetic algorithm with improved local search. This option applies the TS2 algorithm from the earlier slides to the best solution obtained by the mimetic algorithm that copies the best four assignments described in the earlier slides. The value x equal to 4 turns out to produce the best result for a wide range of problems. And the last one is switch. All the previously introduced algorithms satisfy the user determined hard constraint, but this approach accepts all the solution that remains within the minimum preferred requirements interval. New generation are created by adding or removing assignments within the feasible region in the parent schedule. So the result of the combination of taboo search and the evolutionary algorithm is copying entire parts of the parent schedule, that is the diversified mimetic algorithm with random selection and mimetic algorithm with crossover, and the simple mimetic algorithm and simplistic mimetic algorithm and the diverse algorithm turns out not to be the efficient at all. The steepest descent does not succeed in the modification of the new individual into the acceptable solution. In contrast, the copying very tiny partial schedules with the good qualities. We have discovered that there was a considerably high diversity and more freedom to improve the children with local search. We may assume that best X assignments of the schedule influence the rest so much that solutions evolve towards the good quality solution. A multi-star TS with the random planning order cannot compete with the real mimetic algorithms. This proves that longer computation time and variance in initial solution does not lead to the quality that hybrid approach should be. The mimetic taboo hybrid mimetic algorithm that copies the best X assignment behaves extremely well for very complex problems. This outperforms all the other algorithms except switch and clearly demonstrate the benefit of hybrid approaches. Switch, which is a little bit less strict about the selected hard constraint, provides very interesting results. It demonstrates that relaxing the hard constraint to the control extent is often not the harmful as we have expected. Now, moving on to the multi criteria approach. The users of the planning software are confronted with the difficult task of expressing their needs in terms of the set of constraints and corresponding cost parameters. We have developed a multi-criteria approach which attempts to overcome some practical difficulties that partners deal with. The evaluation function sums violation of constraints that are completely different. Yet, it is not desirable that hospital planners have to compare all these different measures. The lack of insight into the characteristics of the solution space often leads to very poor parameter settings. Experiments teach us, for example, The higher value of cost parameters can give the rise to the high barriers in the search phase and make it even more difficult to find a better solution. Multi-criteria modeling allows users to express the importance of criteria according to their own preferences. The approach bears more reasonable to the customs in the hospitals than the cost function approach, and it supports better control of the compensation between the constraints. The nurse roasting problems are generally unsolved in terms of satisfying all the constraints that the planner initially stated as hard. They usually have to soften some of these constraints. There is considerably scope for the uptake of multi-object methods, which promotes a reasonable approach for searching for compromise between conflict objectives. Now moving on to the multi-criteria model for nurse rostering problem. The author applied compromise programming, which is based on the concept of the distance to an ideal point. Each schedule is represented as a point in the criteria space. For real-world problem, the solution that correspond to the ideal point do not usually exist. The anti-ideal point is represented by a schedule with the worst value for all the criteria. In general, the multi-criteria approach has the potential to do more accurately than the um, methods that employ in the single evaluation function. As a result of which, the proposed multi-criteria approach is very promising for nurse rostering. Conclusions are drawn from the experiments on the real world. Test problems are reported. The approach is particularly appropriate for treating completely different criteria. Users determine the weights of each of the soft contents and thus set of relative priorities. They can be controlled, compensated by this constraint by manipulating the distance measures. In general, this multi-criteria approach has the potential to do more accurately reflect the daily real-world situation in the hospitals than the methods that employ a single evaluation function. So to conclude this presentation, I just want to revise whatever we have learned today. So it is pretty much clear that to create a schedule for anything is much more complex than we have thought before, because we have like lots of constraints and we need to satisfy all these constraints. So the time for automatic schedule generation can be tailored to suit the time available by selecting the appropriate search heuristics. The solution method provides an unbiased way of generating the schedules for all personnel members. It enables simple verification of the constraints, helps redefine unrealistic hard constraints, and thus leads to an overall higher satisfaction amongst the personnel as it manifests in many applications. All these algorithms deals with an extensive set of soft constraints, of which many are only valid in the healthcare industry. So that's what we have for this presentation. Thank you.